Guys, I just wanted to give you a little hint on how to answer these questions because we didn't manage to go through them in the lesson today. So I'm not going to do the whole questions for you, but I just want to give you a little nudge in the right direction. Okay, so for the first question, it says find the equation of line L1. So that means we need to know, in particular, the value of M and the value of C. Okay, M is the gradient and C is the y-intercept. Well, we can see that the y-intercept is just 1, this point here. So we know straight away that's going to be 1. But we don't know what the M value is, the gradient. So we need to work out the gradient. To find the gradient, you need to do rise over run. And you also need two nice coordinates in which to use for your little triangle. Now, the problem with this line is if you go this direction, there's actually no nice coordinates that it crosses through. It doesn't go nicely through the grid. And what I mean by nicely, I mean like through a cross, like that. Okay, so if you go the other way, though, you can see that this line goes through this cross at this point. Okay, so we can take those 2 points, use those 2 points to find our gradient, which I'm confident you guys will be able to do. Okay, next one, find the equation of this line. Again, we've got our y-intercept, so that's going to be the C value. And then we need to find the gradient. Now, if I'm looking for another nice point, this is quite a nice point because look, the grid goes perfectly through the line. So my 2 points I'm going to use are these 2 points. So my triangle will be like that. This distance is 3. And this distance is going down, isn't it? So it's going down by 2. So I'm going to write -2 there. So that means the gradient for this line is going to be equal to -2 over 3. Okay, that's not the equation, but I'm sure you can work out the equation using the y-intercept. Question 3. Find the equation of a line parallel to L1. So parallel means the same gradient, which means we need the gradient of line L1. Okay, well, we can find the gradient using 2 nice points. Here's one, here's another. That's a change of 1, so -1 and 1. So the gradient of this line is -1. So the equation of a line that's parallel is going to be y equals, for example, -1x. You could just write -x plus, and this could be anything. So I'm going to write +10, because why not? Question 4. Equation of a line parallel to L1 that passes through to 1. So if you look, this is actually the same line as before. So it's going to have to be y equals -x plus c, and we're going to use that coordinate to find out what the c value is. Question 5. Find the equation of a line perpendicular, not parallel, perpendicular, which means the gradient needs to be the negative reciprocal of whatever the gradient of the L1 is. So we need to find the gradient of L1. Let's find 2 nice points. There's one and there's another one. So I can find the gradient. Okay, and say, for example, if the gradient was 5, that would mean that the new gradient would need to be -1 over 5. The gradient isn't 5. I'm just using this as an example. Okay. And then for question 6, same kind of thing, right? The line is the same, okay? Except it needs to go through this point here. So once you've got your equation with y equals your new gradient, x plus c, yeah, so you're going to know what m is, right? This is going to be the negative reciprocal of gradient of L1. So you need to work out this. I'm not going to do the whole thing for you. You need to work out the gradient of L1. Then you can find the negative reciprocal of it, and that will go into this part of the equation. Then we can use this coordinate, substitute it in. So y would be 1, x would be -6. We're going to know what this m value is, right? You'll know what that is when you do it. And we can use that to find out what c is, and then we know the whole equation. Don't forget, at the very end, to write out the equation with your c value. Yeah, so say for example, the answer was a fifth. Let's use this number, -1/5 x. Don't forget to put the plus c, so like plus 10, for example. This is not the answer, but don't forget to write that final answer as an equation. All right. This sheet we also didn't go through. Plot the graph of y equals -3x plus 6. So the gradient is going to be -3. The y-intercept is going to be 6. So I can put 1 point here at 6 for the y-intercept. And if the gradient is 3, what that means is if we go 1 across, we're going 3 down. So 1 across, 3 down would be here. And I can keep doing that. 1 across, 3 down, 1 across, 3 down, 1 across, 3 down, 1 across, 3 down, until I get to the end of the page. And once I've done that, you can then just draw a line that goes through those points. 2.5x minus 5. So that means if you go 1 across, you're going to go 2.5 up. That's what this gradient means. And we're going to have a y-intercept of -5, which is here. So if we go 1 across and 2.5 up, well, that's a little bit hard to plot, but it'll be around here. If we go another 1 across, we'd go another 2.5 up, which would take us to here. All right, we've got another half and then another 2 up. Okay, so we've got another point here. Well, we've actually gone 2 across and 5 up, haven't we? Right, which would make sense because 5 over 2 is equal to 2.5, which is the gradient. So really, we can just go across 2 and up 5, and we can keep on doing that. Across 2, up 5, across 2, up 5. And then we draw a line through it. Now, the other way to answer these questions is to actually substitute values in. So, for example, if we say, all right, well, if x is equal to 4, what's y equal to? And then we put 4 into this equation. 2.5 times 4 in a calculator, that would give you 10 minus 5. So the y value would be 5 because 10 minus 5 is 5. Okay, if we were to put 2 into the equation, right, 2.5 times 2 would be 5. Overall, 5 minus 5 is equal to 0. Okay, and then look, we're actually getting these coordinates that we worked out that I drew on, plotted on a second ago. If I put like -1 in, for example, -1 times by 2.5 is -2.5, minus another 0.5, another 5 gives us -7.5, which means we're going to have a coordinate like here. Okay, again, you can see that lines up nicely with the other ones. But that's the other method for plotting the graph. Again, remember you need to use a straight, a ruler, and a pencil when you actually plot the graph. Okay, question 3. This is a quadratic graph. You can tell that because it's got this squared here, which means it's going to have this kind of shape. To work out those points, what you want to do is you want to get your calculator. Okay, and then we want to write down the equation with brackets and one of your numbers in. So let's put -3 in first because that's the first one. So -3 squared. And then it says plus 2x, so plus 2 and then the -3. And then -3 overall afterwards, right? Because there's a -3 there. Yeah, so we've got x squared plus 2x -3. Okay, see how that relates to this? And we hit the equals button, and it tells me the answer is 0. So I'm going to put a 0 in there. Okay, then I'm going to go back to that calculation I did. I'm going to change everything in my brackets. So that's why you put the brackets there, is that you know what you need to change. So that's going to do -2 now, -2. hit equals again, and it gives you the next value along. Okay, so you keep on going, you do that for all of your values. I'm not going to bother doing it for all of them, but the